Flash flood warnings are in effect in Southern California as one of the worst Christmas storms in recent years that brings heavy rain and fears of deadly mudslides.
California didn't just get hit by a storm, it was targeted by a conveyor belt of water in the sky. For 11 straight days, atmospheric rivers slammed into the state with a force meteorologists say they've never measured at this scale. Levees failed, highways disappeared, entire neighborhoods were swallowed by water that rose faster than emergency crews could respond. 3 people lost their lives. More than 200,000 were forced to evacuate. Hundreds were rescued from rooftops. And scientists now warn this wasn't a freak event. It may be the blueprint for California's future. The fire hose from the Pacific. An atmospheric river is exactly what it sounds like, a narrow corridor of concentrated water vapor moving through the atmosphere. California depends on them. In a typical year, these storms deliver up to half of the state's water supply. But in late December 2025, one arrived that changed the conversation. This system carried an extraordinary volume of moisture. At peak intensity, estimates suggested the vapor transport rivaled many times the average flow of the Mississippi River. Stretching thousands of miles across the Pacific, it connected subtropical waters near Hawaii directly to the west coast. When it made landfall, it didn't move on. It stalled. Rainfall rates in mountain regions exceeded 4 inches per hour. Coastal ranges were drenched. Valleys filled. Soil that had endured years of drought suddenly had no capacity left to absorb anything. Rivers swelled beyond flood stage within hours. Levees strained. Water spilled over. Christmas Eve. The first impact on Christmas Eve, 2025, the first wave hit Northern California. The Bay Area recorded several inches of rain in just hours. The Russian River surged rapidly, flooding communities that had started the day dry. In Sonoma County, deputies launched boats into suburban streets. Families were rescued from second-story windows. Children clutched pets. Elderly residents were carried through waist-deep water. Farther south, urban flooding overwhelmed storm drains. Freeways became rivers. Drivers abandoned vehicles as water climbed up doors. In Southern California, hillsides stripped bare by wildfire couldn't hold saturated soil. Debris flows cascaded downward, carrying mud, rocks, and trees at terrifying speeds. And the rain didn't stop. Day after day, the same region absorbed relentless precipitation. Records fell across Stockton, Modesto, and Sacramento. The Central Valley began to resemble an inland sea. By December 28th, rivers across the state were running at or above flood stage. Then the levee failures began elsewhere on the west coast, including a breach along Washington's Green River, underscoring how vulnerable aging infrastructure had become. California's own system, roughly 24,000 miles of levees protecting 23 million residents and trillions in property, was under historic pressure. A brief pause. Then, round 2. The first storm weakened at year's end. California got 48 hours of uneasy calm. Then, the second atmospheric river formed over the Pacific. On January 2nd, 2026, it struck. Stronger, wider, laden with even more moisture. San Francisco and surrounding areas saw several inches in a single day. Urban neighborhoods flooded, public transit tunnels filled with water, emergency response systems activated at full capacity. In Sacramento, the American River climbed toward levels not seen since the catastrophic floods of 1997. At Folsom Dam, spillways roared as operators released massive volumes to prevent overtopping. The sound of water thundering through gates echoed for miles. North of the city, smaller levees protecting agricultural land began to fail. Residents had minutes to evacuate as water surged toward homes. In Los Angeles, burn scar zones turned deadly again. Hillsides behaved like pavement, shedding rain instantly. Debris flows tore through neighborhoods at highway speeds, burying cars and slamming into houses with crushing force. Major highways, Interstate 5, Highway 101, Interstate 80, shut down in sections. In the Sierra Nevada, blizzard conditions dropped feet of snow, while winds exceeded 100 miles per hour. At the height of the crisis, more than 500,000 utility customers lost power. When the second storm moved east on January 7th, the damage was staggering. But meteorologists were already tracking another formation offshore. the pattern behind the chaos. What frightened scientists wasn't just the intensity, it was the pattern. These storms were not isolated systems. They were connected by a larger atmospheric configuration, a semi-stationary wave pattern in the jet stream that funneled subtropical moisture toward California repeatedly. Instead of one event, the state was caught beneath a conveyor belt. Researchers at University of California, Berkeley began analyzing satellite data in real time. They observed atmospheric rivers behaving in ways models hadn't fully anticipated: stronger vapor transport, longer duration, and repeated impacts over the same saturated regions. Soil moisture levels reached depths rarely recorded. That detail matters. Flood severity depends not just on rainfall, but on how wet the ground already is. By early January, California's soil was saturated to several feet deep. Every additional storm meant immediate runoff. Every additional inch meant more flooding. February, the breaking point. On February 16th, another atmospheric river made landfall, classified at the highest level on the atmospheric river scale. Los Angeles experienced one of its wettest days in over a century. Mountain regions received more than half a foot of rain. Winds approached hurricane force in some areas. Debris flows dwarfed those of January. Mud buried vehicles beneath 10 feet of earth. Roads vanished. Entire neighborhoods were evacuated for the second or third time in 2 months. In Northern California, coastal flooding combined with high tides to inundate waterfront districts. In the Sierra Nevada, snowpack ballooned to well above seasonal averages. But warmer conditions meant that at lower elevations, precipitation fell as rain instead of snow. Rain runs off immediately. Snow stores water for gradual release. Instead of slow replenishment, California received violent delivery. By late February, the state had accumulated roughly 150% of normal precipitation since December. Reservoirs rebounded dramatically. The drought that had gripped California for years was declared over, but the cure came at enormous cost. Economic damage exceeded $12 billion. Agricultural losses mounted. Tourism suffered cancellations in the hundreds of millions. Insurance claims soared. And still, the jet stream pattern showed little sign of breaking. Climate signals scientists increasingly link the intensification of atmospheric rivers to a warming climate. For every degree Celsius the atmosphere warms, it can hold about 7% more moisture. That added capacity means when storms form, they have more water to release. Studies also indicate atmospheric rivers are gradually shifting poleward and increasing in intensity. Some researchers now argue the atmospheric river rating scale should incorporate soil moisture data, because saturated ground can turn a moderate storm into a catastrophic flood. Better forecasting can improve warnings, but it cannot prevent physics. The Levee crisis. Perhaps the most alarming revelation from winter 2026 wasn't just meteorological, it was infrastructural. California's levee network received a near-failing grade from the American Society of Civil Engineers even before these storms. Many levees began as agricultural embankments decades ago. They were never engineered for sustained atmospheric river pressure. When levees fail, water rushes in quickly and drains slowly. Protected areas become bowls, trapping floodwater. Repair costs are staggering. Upgrades take years. Funding lags behind risk, and each new storm compounds structural stress. What comes next? By March, meteorologists were already tracking additional atmospheric rivers forming over the Pacific. Communities faced a sobering realization: preparation is not protection. Evacuation fatigue set in. Some families decided to leave flood-prone regions permanently. Real estate listings surged in vulnerable zones. Ironically, the exodus wasn't driven by drought. It was driven by too much water. A new normal. The atmospheric rivers of 2026 will be studied for decades, not simply for their intensity, but for what they revealed. California depends on atmospheric rivers for survival. Without them, reservoirs empty and drought tightens its grip. But when those rivers in the sky grow stronger, slower, and more frequent, they become something else. Geological forces. They reshape landscapes, test infrastructure, displace communities, rewrite risk maps, and they are not done. Another plume of moisture is forming over the Pacific. It will move east. It will encounter soil that has barely dried. It will test levees all already weakened. The question is no longer whether atmospheric rivers will return. The question is how California will adapt to a future where extremes, drought, and deluge arrive in rapid succession. Because the rivers in the sky are growing stronger, and the ground below is running out of ways to hold them. If you found this deep dive valuable, make sure to like, share, and subscribe for more in-depth coverage of the climate patterns reshaping our world.